So in the first example, what we want to do is we want to write a program that computes the sum of all the perfect squares in the range from something to something and prints the values on the screen, okay? So just to be able to write this algorithm, you need first to understand what is a perfect square. A perfect square is a number that its square root is in fact another integer. For example, 9 is a perfect square because its square root is 3, which is an int. But 8, its square root is not an integer, it's not a perfect square, right? What we are asked to do is from 20 to 3, are you seeing the writing? Okay, yeah. To 3000, we want to identify the squares, the perfect squares, and Cameron, yes, the examples, I will post the slides, don't worry, and the recording will be there as well, right? So, so we want to identify the perfect squares in this range and get their sum. Let's first try to see how to identify them. Can someone imagine that? How can we get, first of all, how can we determine if a number is a perfect square or not in an easy way? Any ideas? And you guys can unmute if you want to comment. That's okay for now. Just a square a number. Okay, but Daniel, if you square the number, it will give you the result. What we're looking after is, okay, so this is one thing. Yes, you can square the numbers starting from 1, but you have a specific range from 20 to 3000, right? Multiply by itself. Yeah, so guys, we are not looking into, that's just, let's focus, right? We are not looking into, so what we want to identify is the perfect squares in this range. Yes, I can take numbers one by one, square them, and then see if the result is within this range, which means the result itself would be a perfect square. That's a way, that's correct. But what is an easy way? It's a trick that we can utilize from previous 2 lectures. Does T have a square root function? Yes, C has a square root function, the math.h, and we can use it in this example. So Rafi, what will you do if you are allowed to use a square root function? What do you think? Any idea? So, okay, let me see the chat. If a square root of a number is an int, great. So how to check that? You guys are moving in the right direction. So using square root and then check if this square root is an int. How can I know whether this square root is an int or not? And check that the reminder is 0. Oh, but there is no reminder of square root. Reminder is just for okay, Daniel, int square, double square. Yes, that's casting, Moaz, that's correct. So you guys went into the right direction. So the thing is, square root function. So if I'm taking every number here, so I'm writing my algorithm. So I'd say for every number here, call it I. The idea is if the square root of I is int, then that's a perfect number. How to determine this? You guys said it correctly. Using the casting and checking whether it's int or not, because square root returns generally a double, because not every number has a square root that is int. So what I can do is say, okay, I will do the square root of I. This is returning double. Then I will cast this into int. One last step that you didn't say is, if you cast this into int, but it was something that is not int, for example, 3.5, right? If you cast this into int, x will be, what will be the value of x? Can someone say? It will be 3, correct. Then that means it's not equal to this. What is the condition that this I would be a perfect square? Is that its square root result, which is double, is equal to the casting of the int, correct? I will come into your comment now, Desmond, but let's focus on this. It wouldn't, in fact, be more effective, but let's see, right? So given that we have this algorithm now, let's see how we can try to write this into online GDB, right? And I will encourage you to kind of also not just look into me, but writing it, but try to write it yourself as well. The main purpose of this example is to show you how we can have a useful use or an effective use of casting to do something meaningful, okay? So first of all, I want to use the square root, so I have to include the math.h, right? And then maybe if I do this as white, let me see. Just move this here. Is that better? I guess this might be better for visibility. Okay, let me know. If you think the other one was better, let me know. And then now I'm defining, first of all, I would define my, call this input, for example. And then I define my input, I would say input square root, something like this. This is integer square root. And then I define the usual double square root. And then I have my range, which is for, okay, here I would have iteration. But okay, I'm using this as the input anyway. So I'm saying for input equal, what is the number we said we are going to use? Is it 300? Let me see. It's 20 to 3000, okay. So input 20, input less than 3000, input plus plus. What I want to do, I want to get the square root of the input. So I would say, and this is a normal one. So I would say this is I will use the double, and square root is, if I remember correctly, it should be that. And then I'll do the square root of my input. And then I will cast, so I will use the integer variable. Here comes the trick. You just simply do this, right? And now you check, you say if I square root equal d square root, then maybe I just print for now. Let's forget about the sum. And to print what I want to say, my input. So in this case, it should be d, because I know it's an int, is a perfect square. And then I will just put my input here. Good. Let's see if this works. Does this make sense to you? I hope it works.
Didn't you just assign I square root to d square root, and then you're checking the equality right after? So wouldn't it always be true?
That's the trick, Arjun. Okay, that's you asked a question that is vital here. So let me comment on that. So Arjun is saying the following: I assign this variable to this variable. That means if I check equality, they will be the same, right? But no, because this is casting, and this is what I want you to understand. If you cast double to int, then the result will be the truncation, right? Let's take an example. Assume that d square was 3.5. When you cast it to the integer value, it will be 3. So if you check equality, they will not be equal, right? They will only be equal if the value of the double variable, so let's say this is the double one, it will result in an int like that. When they will be equal only if the original double value was really an int, correct? And doing that, this will only happen if the original input was a perfect square. Is that correct? Maybe one thing I'm missing here based on the compiler is maybe I need to cast this into double to the equality for the equality to work. But let's check if it works, right? Let me pick questions. Again, I see many things on the chat. You guys, are you commenting here, or you're just, please, if you have questions, just add this into brackets as we said before, such that I don't have to read all these 53 messages if they are not questions, right? Let me see. There is the include on the top of the main. Yes. Okay. I have done the include already, if this was a question. Good. Okay, so let's try to run and see. Check our luck here. Okay, 25. Oh, I forgot something. Maybe formatted new line, right? Okay, so it tells you 25 is a perfect square, 36 because 6, fine, 5, 6, 7, 8, 9, 10, etc., etc., etc. It works, right? So this is the trick. Let me go back to Daniel's question, which is, would it be more better, or maybe at least, and it's another way of doing things, if you take the if you do squaring every number of int, for example, starting from 1, and then see if it's between 25 and 30, right? So it's a different way of writing the code. Yes, this in fact will work, because you know if you take the square of an int, it will be an int, and if it's within your range, that means perfect square, right? So you can do this as well. But I have done this way because now, first of all, previously you needed a for loop that is starting from 1. Here you are just starting within the range, so it's better readable. The second thing, I wanted to show you how to better use the casting, because this is what we covered in lectures, in last 2 lectures. And now it might be clear to you why it might be useful to leverage the casting as a trick, right? In order to whether they are equal, both values will be casted to double, right? So that's a good question. This is what I said. If it doesn't work, maybe I need to cast this to double. But yes, generally you are correct. Remember what we said previously in the Wednesday lecture is that if you have an expression that have different types, we will cast everything to the wider type. Here we are comparing int and double. So what will happen by the compiler is that everything will be casted to double to check the equality. That's correct. Good. So now, after we have done this, let's see if I want to do the sum, because the question was mainly about the sum, right? So now after printing this, maybe I need another variable here that I call sum. And then I would say sum plus equal input in this case. Is that correct? Am I missing anything? What do you think? A question to you guys. Am I missing anything?
You just messed up the printf when you hit enter.
Oh, that's bad. But that was unintentional. This wasn't my question, but thanks. Okay, so is the code correct, or there is something that is missing? Initializing the sum amount. That's correct. Sarah as well. So because remember what we said before, I guess this was even the first lecture, is that variables in C are not initialized by default, right? So they take whatever value they have in the memory assigned to them, which might be garbage. So you need to initialize to 0 if you want your sum to work correctly, right? So here I want to make sum equals 0, right? Good. Okay, good. So by this, maybe at the end, I would just print the sum. I would say the sum of all perfect square in 23,000 range is sum. Another thing, here we are not including, so we are including the 20, but we're not including the 3,000, correct? So if we're talking about math, we are talking here about a range between 20, so 20 is included, but in fact, 3,000 is not, right? This is how we write it usually in math, right? But if we were to add the 3,000, I mean, we don't know whether yet 3,000 is a perfect square or not. It can be, right? So what I need to do is to do this, right? If I want, right? So by doing this, you are also including the 3,000. So, okay, that's the code. What if I want to write this as a function? Because we have covered functions and we said this is the right way of writing things. So what I want to return from this function, the sum, which is an int. So I define my return to be int. And then I may call it sum of, I don't know, perfect squares, right? And then let's say for now, I don't take any input because my range is fixed. Then I will do this code all there, right? And then maybe at the end, I would just return sum. And then here, to call this function, this is function body definition. To call this function, I would simply say maybe doing exactly the same thing. But here, call my function instead. So it would be of perfect squares. So by doing this, you are calling the function, right? A simpler way of doing this is just you define an int sum here equal that, and then you just print the sum, right? Doing it in a two-step way. Good, because this is returning int. So whether you put it here or you define it in a variable and then put the variable here, it's the same thing. Good. So what we have done here is we define the function that is doing exactly what we want, and we call it here. This is the function calling. We said the function has three things, right? A prototype, a body or implementation, and caller, right? Here we called the function, here we implemented it, but we didn't have a prototype. What is the reason for this? Why we didn't need a prototype for the function? I want the tutorial to be more interactive. Just we'll make sure don't need specifier in the printf. Yeah, that's exactly correct. It should be D, thanks. So let me see the chat here. So what I was saying is why I didn't need a prototype, because it's all in one file. No Nicole, that's not the reason. Because it's before the main, Zauhan, that's correct. Because we added it before the main. What we said is you need the prototype because the compiler will start executing from line 31, the main, right? Move line by line. In the first line, I find that I'm calling this function. But if I have done this, you know what, maybe let's try this first. Okay, it works. Both at the main and at the function itself gives the same number. But now let me move it after the main and try to run. Oh, there is a problem, right? Here is just a warning, but in fact, some compilers will give you even like a syntax error. And the reason is it says implicit declaration of the function. Why it's implicit declaration? Because the compiler started from here, it found a call for the function, but it didn't find the implementation yet. To remove this warning or error, we need to add a prototype here that is exactly the same line as the function definition with a semicolon. If we do this, you will not get the warning or the error, right? And the reason is you already told, you have already told the compiler that there is a function coming that is called that. So when you incur it in your main, don't worry about it. I'm implementing it later. This is called function prototype. This is the function implementation itself, or sometimes called definition. And this is the function calling, right? So these are the three functions, different aspects of dealing with functions in C. Let me see if there are questions before I move forward. Do you guys have questions? So is that what you would put in the .h file? Muaz, that's a good question. Because we are using the online compiler, it might be a little bit problematic to add multiple files, but you are correct. What I would put, okay, so what I would do is I would take this into the header file. Let me call this, I don't know, my perfect square, something like this, my perfect square.h. And then for the implementation, this would be your exactly same thing, but it's .c. And here you have to include, come on, you have to include this one. Okay. And then coming in the main here, you also have to include that, right? You would do that. Right? So if you are splitting things into files, right? This is the first file. This is the main file. Call it anything. This is the C file for function. implementation, and this is your H file for function implementation. Talking about the lab, right? Let's think of the lab, because this thing that you have seen yourself, right? So in the lab, we have questions.h, which includes all the header file, all the prototypes of the functions. We have questions.c, which is the one that you are implementing. And we have the main in the test cases.c. And in fact, not the test cases.c, if I remember correctly, it's in all tests, but basically it's one of the test files. And this file, if you look into it, it will include the questions.h, right? So it's exactly the same thing. You added different functions in C and header files, and then you included the header file in somewhere else where you have your main, such that you can call your functions from the test cases. I hope this kind of multiple file thing is clear now. Let me see if there are questions. Okay, good. So let me, so we can take this question further. I don't want to spend more time on this to look into the remaining question, but it's just a good exercise anyway. So something we can do is, instead of just having this as a fixed range, let me go back to all, okay, let's even keep this. Instead of having this as a fixed range, I can even take start, end, correct, as my range, and here deal with the start and the end, right? What I have done here is, instead of not taking any inputs, I'm making my function flexible to deal with any range, right? By taking 2 inputs. I have to update my prototype as well. Correct? And then here, I need to pass something. If I'm passing 20 to 3000, it should give me the same result. But now, in fact, I can do 1 to 10, right? And then if it's 1 to 10, what should I get as a square? 9, right? It's only on 4 as well, 4 and 9. So let me try to run this, and hopefully it should be okay. Oh, because I added this include bad thing here. Okay, so you get 1 because 1 is the perfect square of itself. 4 and 9, right? But here we are still printing the same message. So if I want to update this printf as well, what I can do is, it would be d-d, and then here I would add start, end, and sum, right? So it's a good implementation to have multiple inputs and see how they are formatted, right? And I do the same thing here. But here I don't have a start and end. I would just give the number that I provided to the input. What I have done. This is a start and end, which is correct, but in the main, I don't have a start and end. This should be what number I give, 1 and 10. Right? And then if I run, okay, the sum between this range is, it's returning the sum. So 1 plus 4 plus 9 is 14, right? 14. Is that clear? Do you guys think that doing this kind of exercise, like online together, and we try different alternatives and see how we can think about problems, is useful? Okay, good. Okay, so let me know, again, like, to make it more useful, have it more interactive, like ask questions. Like if I ask a question, like try to think about it and address it, even if it's wrong, but it's good to address the way you think, because this is the most important thing in programming, is not being able to know the syntax. It's more about like the mindset, right?